Hello friends, welcome to G-Centric. So now in this lecture we will see how this 120 degree phase displacement have come into the picture. Okay, so this drawing is not so good, please kindly adjust with this. Okay, so now this is a stator frame. Okay, basically it's a synchronous generator. Okay, this is a synchronous generator through which we will be getting the electrical energy, right? Or we will call this as alternator. Right, both these names we will call this as alternator or synchronous generator. How this turbine, there will be a turbine. Okay, we have seen the electricity generation plants. Okay, where there will be, if it's suppose a steam generating station, then we'll be having a turbine over here. Okay, this is nothing but rotor. Okay, this is rotor, which is the rotating part. Okay, in this there is a north pole and here it is a south pole and it is rotating anti-clockwise. Okay, it is rotating anti-clockwise. Okay, so how does this rotor rotate? It rotates with the help of the turbine. And how does the turbine rotate? It rotates with the help of the high pressure steam. Okay, that steam will rotate the turbine and in turn it will rotate the rotor part. Okay, through which there will be, these are called as slots. The conductor will be made to cut each other. Okay, when they cut the voltages, there will be a displacement of 120 and 240 degrees. Okay, so this is nothing but what we will call these as slots. Okay, and this is the stator frame. It is the static part. Okay, now in this thing, okay, in these slots I will place the conductors. Okay, so here I will put a dot converter, which means the wire is coming out of the slot. Okay, now when it is coming out of this slot, okay, there must be one more slot at 120 degree displacement. Okay, and one more slot at again 120 degree displacement. Okay, this is the dot polarity. Now when it is coming out, then somewhere it must have gone inside as well, right? So here this is the 90 degree displacement. Okay, this is the 90 degree displacement where here the cross polarity will be there. It means that we have put a wire over here and we are drawing it from other end. Okay, drawing the conductor out of this slot, we will denote it by dot polarity, whereas putting inside this slot, we will denote the conductor by cross polarity. Okay, it should be opposite to this one. Okay, naming, if this is A, then this will be A dash. We can call it as R also, R, Y, B. Okay, similarly opposite to this one. Okay, if this is B, okay, or Y dash, Y. Okay, then here also it will be B dash. Okay, so this is B dash, Y dash, and for this one it is C, B. Okay, so here it will be cross polarity C dash and B dash. Okay, so now this is when we have the rotor rotating anti-clockwise, we will get a positive sequence. This we will see in the in few minutes. Okay, what do we mean by positive and negative sequence? Okay, so now basically I want to do a star connection. Okay, what is star connection? The three similar ends will be connected and clubbed at one point and the rest three will be open at another point, right? So now if I draw over here, okay, I have these three coils. Okay, these are the three coils: A dash, B dash, C dash. Okay, or R dash, Y dash, B dash. Okay, these are the three coils and here are the three coils that I have mentioned. Okay, so now this is A dash. Okay, what I have said, similar ends are connected together, right? This end, this end and this end, let us take as connected together, and the rest of the three are left open. Similarly we will do here that only. Okay, so let us take this A left open, B also left open, C also is left open, but similar ends again, three ends should be connected. So I will connect this C dash with B dash and A dash. Okay, and this point I will call it as neutral. Here also I will call it as neutral. Okay, so how is the star connection that we have already studied? It will be, okay, so this is one coil. Okay, so this is second coil, and here we have third coil. Now see here, A dash, B dash, C dash are connected to each other. So this is B dash B, C dash C. Okay, so I will take this over here, and from here I will draw a neutral. Okay, neutral I have taken over here. See, now this common point over there is nothing but neutral. Okay, so this is A, and in between them there will be a phase voltage generated. So this is VAN, VBN. Okay, over from here to here it is, sorry, this is VCN, and here VBN. Okay, so this is how, that is, we have done for the star connection. Now if we see, there is a phase sequence, right? What is a phase sequence? We will see now. Okay, before that, how do we come to know that whether A only will come first, B only will come second, and C will only come third? How do we know that? Okay, that we will see by drawing the graphs for all the three sequences. Okay, so now I will draw again the star connection to understand with a good clarity. Okay, remember this rotor direction is anti-clockwise. Okay, then only we will get the positive phase sequence. So now this is a coil A dash, then we have here C dash C, and we have here B dash B. Okay, this is neutral wire, and this is A, B and C. So this is VAN voltage, VBN voltage, okay, and VCN voltage. Okay, so now I will draw a phase sequence for this one. We will take this as time axis and this as phase voltage sequences. Okay, let us take now as V. Now I will consider this A as starting sequence with 0 degree. Okay, so how I will represent this one? Okay, so this is starting from 0 degree, and this is VAN. Now after that B follows with a phase displacement of minus 120 degree, right? So now I will draw, where is minus, it will come down, so it will be lagging behind, right? So I will draw over here. Okay, kindly adjust with this one. Okay, this is VBN. Now after this VBN, again VCN will lag with this one, right? So when it lags, I can draw like this. Okay, all three are cutting each other with phase sequence of with phase displacement of 120 degree. Okay, so this is VCN, right? So now what I am seeing is, here I have got first VAN from 0 time axis I am seeing. So first I can see VAN, after that I can see VBN, and after few minutes I can see VCN. Okay, so what is the phase sequence if I draw over here? Okay, first is VAN, after that with a phase displacement of minus 120 degree. Okay, if I indicate like this, phasor rotation will go like this, right? How does it go, phasor rotation? So this is minus 120 degree, phasor rotation will be anti-clockwise, anti-clockwise. Okay, so this is VAN. Since it is going opposite to the phasor rotation, here it will be minus 120 degree, and here we have got VBN. Similarly for this, again there is a minus 120 degree where I can see VCN. So this is total, from here to here it will be minus 240 degree, from here to here it is 120 degree, minus 120 degree, and from here to here along with the phasor rotation it will be positive 120 degree. I hope it will be clear. Okay, so this is the phase displacement. Now I can write this as, okay, this is phasor rotation, it will be always anti-clockwise, but phase sequence will be clockwise. you have to read phase sequence in clockwise. How? See, first I can see A, then I can see B, okay, then I can see C. Okay, so this is one thing. Now if I got delayed to see this A, but I saw first B, so what will be the phase sequence? B, okay, then C, then A. Similarly, again I could not see both A and B when I was seeing the phase sequence started from C. Okay, phase sequence goes in this way now. First comes C, then A, and then B. Okay, so this type of ABC, BCA or CAB, we call it as positive phase sequence. Okay, we'll call it as positive phase sequence. Now I can take this. These are all equal voltages. So this is balanced supply voltage. Okay, it's not unbalanced. Okay, since they are all same voltages, I'll take VAN equal to VBN equal to VCN equal to VP. Okay, so now I can write VAN is equal to VP angle 0 degree, where VP is the RMS value. Okay, VBN VP of minus 120 degree, VCN VP of minus 240 degree or VP of plus 120 degree. So this is for the positive phase sequence. When did we get this positive phase sequence? When rotor was moving anti-clockwise. Okay, now we will see when rotor moves clockwise what we will get. Okay, so now when you add, there is one more concept also, VAN plus VBN plus VCN. When you add these three balanced phase voltages, you will get the 0. The sum will be equal to 0. So how you will solve this one? Basically open this up. Okay, so this VP you can write it as VP cos 0 plus VP sin 0. Okay, JVP sin 0. Okay, do this all together, you will find you'll get the 0 value. Okay, coming to anti-clockwise, rotor rotation is completed. Now rotor we will move it with clockwise sequence. Okay, then we will see what will happen to these phase sequences. Okay, so this was the rotor. We had here north and south, and now we will move it clockwise. Okay, so when you are moving clockwise, first what you will encounter? First is A. Okay, then here in the diagram, here it was with a dot polarity C, right? So first, then second will come C, then B. Okay, now if I see time delay, then here also we can change here VAN, then second will be VCN, and here it will be VBN. Okay, so phase sequence follows the CBA BAC. Okay, first I will see VAN, then I will see VCN, and then VBN. So this type of sequence is called, this is 120 degree minus, and this is also minus 120 degree. So total it will be from here to here minus 240 degree. Okay, so this is negative phase sequence. Okay, negative phase sequence. Say for this also, if you assume it to be VP, all the voltages, then you will get VP equal to VAN equal to VP 0 degree, VCN is VP minus 120 degree, VBN equal to VP plus 120 degree or VP minus 240 degree. Okay, so this is the negative phase sequence. It follows in this way. Okay, so I hope this idea of the generation of three-phase voltages, how it will be occurring in the synchronous generator or alternator. Okay, and these are similarly again here also, when you add all these three, VCN plus VBN, you will get 0 as the value. Okay, this is for the balanced. Okay, unbalanced we will see in upcoming lecture. Thank you.